This presentation is specially dedicated for students, hobbyists and all others who are familiar with electronics and really interested in how a laser rangefinder works and what is inside it. For beginning, I'll shortly observe all types of laser rangefinders I know and then consider one of them more in details. Time-of-flight rangefinders typically have long range to the several kilometers, middle accuracy from centimeters to meters. They are very fast but unfortunately expensive, and main application areas are military and hunting aiming tools, as well as landscape and construction scanning tools. The next type is the phase shift laser rangefinders. They typically have middle range around 100 meters, good accuracy several millimeters. They are slow but affordable, and main application is buildings construction. Next one is triangulation rangefinders. They measure angle of reflected beam. They typically short range around several meters, good to poor accuracy, not so fast but very cheap. And the main applications area are industrial techniques and robotics. By the way, one on the picture uses narrow light instead of laser. And the last one is the interference rangefinders, but I haven't enough information about them, only my assumptions that they are running on a very short range and very accurate, so I won't consider them at all. Triangulation rangefinders are quite simple and not so interesting, so I won't consider them too. Time-of-flight rangefinders in opposite are too complicated because using very high-speed circuits, so I will skip it too. And finally, phase shift rangefinders are most attractive for me, and I will consider it in details. This is a handheld device, and according to the manufacturer data, it's running on distance up to 50 meters and as accurate as 1.5 millimeters. Now let's consider basic principles of operations. We write this transmitter, receiver and the target at a distance d. So transmitter emits sine wave towards the targets, then it reflects from it and goes back to the receiver. As you can see, received signal has a phase shift relative to transmitted signal, and in these terms the distance d can be expressed as the following. In the formula, n is the number of periods. In that particular case it is 5. L is the wavelength and phi is the phase shift. The very simplified block scheme for such device may be depicted as in the following. On a picture, the reference oscillator generates a high frequency signal for a transmit circuit. Then transmit circuit generates amplitude modulated signal and transmitted to the target. Reflected signal is then returned to the receiver and its frequency downshifted to a lower frequency band by a mixer for more convenient processing. And finally, output signal is a phase shift between input signal and a reference oscillator. Typically, transmit circuits consist of amplitude modulator and buzzer driver, while receive circuit consists of avalanche photodiode, high voltage BOSCH generator for APD, and transimpedance amplifier. A phase detector might be implemented in several ways, and one of them is a quadrature demodulator and set of filters. So now I'm going to check it on a practice and disassemble one of DLE40 devices. I've just bought DLE40 device. It's still in box. This is a warranty. It became useless within several minutes. Batteries and device. Hope it's working well. In order to disassemble, a T6 screwdriver, knife, a vacuum pump and soldering iron are necessary. So let's prepare it. 6, 9, often found something kind of here, and also another very useful tool, just in case something goes wrong, might help. So let's start the assembly. The first step is unscrew 2 T6 screw from here and here, then 2 6 screw in battery compartment, remove front and back cover and the keypad. As you can see, the device is soldered to 2 leads coming from battery compartments, so no chance to disassemble it without unsoldering. So what we have? We have a keyboard, LCD screen, receiver optic, transmitter optic, curtain dryer, and curtain behind the dryer. Curtain works like a reference target while measurement or while device calibration. Then the curtain is opened, it's like that, and laser beams goes directly through it. Transmitter optics to the target, reflects from target and goes to the receiver optic and then to the receiver. Then the curtain is closed, it stays like that, and laser beam reflects from curtain, goes directly to the receiver, passing transmitter and receiver optics. The next step is remove PCB from its base. PCB is mounted by 4 screws, 2 of them is right there, and 2 of them behind LCD display. LCD display is mounted on the 2 source sticky pads on both sides, here and here, so you can just pull up it gently. So these are 2 screws, and also curtain connection have to be unsoldered. Now we have a naked PCB, and it's right time to consider more in details. Okay, we continue. This is a DLE40 PCB, and it consists of several main blocks. The first block is a power unit, and it provides power for all circuits. The next one is a control unit that controls LCD display, keyboard, APD BS voltage generation, modulator behavior, and curtain switching. The next one is an APD voltage generation circuit. It generates high voltage for APD device. The next one is an input signal filter and amplifier. It is connected directly to the MCU ADC channel. Then frequency shift circuit. It shifts incoming high frequency signal to the lower band. And finally, laser driver and modulation circuit. So this is the right moment to consider these blocks closely. So I'll start from power supply part numbering and move into schematic view. Here we are. This is a battery connection, input voltage, filter circuit, no circuit might be its additional voltage protection or input filter. Then 3-3 load drop positive voltage regulator. It provides power for whole circuit. Then several switches for power on logic, and finally input voltage divider for battery level monitor. The next block is a device control unit. I'll do the same, add part numbering and move to schematic view. As you can see, nothing special is here, it's quite trivial. It consists of clock generation circuit, the curtain driver switches, the switch curtain up and down. From the MCU connection schematics, you can see that the SPI interface is used to communicate with modulator circuit, and also that cable scanning lines are connected directly to the MCU. This is an APD BOSCH generation circuit, and its schematic looks like the following. As you can see, this is a modified boost converter with 3.3 volts applied on its input and more than 100 volts on its output. As you can see, there are several connections to the modulator IC, and the modulator IC regulates output voltage using the transistor Q9 and divided output voltage at this point. The switching frequency is applied to this switch and is generated by the MCU. And MCU in turn regulates output voltage by writing proper values to the modulator registers. The next block is an input signal filter and amplifier. It is constructed on two operational amplifiers, and its schematic is as the following. The first stage is implemented as a low-pass filter, which is connected to the frequency mixer output and removes high frequency component after frequency shift down. The second stage is implemented as a bandpass filter, tuned exactly to the intermediate frequency. It is around 4 kHz, and it's output connected directly to the MCU analog digital conversion channel. Now let's consider two remaining blocks attached to the modulator IC. This is frequency mixer and laser driver modulator. This is a frequency mixer. As you can see, one frequency is received by the APD device from the receiver optic, and another one is applied from modulator IC. Here is an APD high voltage BS from boost converter. It is around 100 volts. And this is an APD output to the input signal filter amplifier. This is the modulator IC, and as you can see, it is fed by the same clock signal as the MCU, and communication with the MCU is implemented using a SPI interface. The last block is a laser driver modulator circuit. Laser is here, but unfortunately I have no ideas how it works, so nothing to comment here. So finally, after all main blocks are observed, it doesn't look so complicated, and as the SPI communication protocol is quite simple too, it seems to be very effective to get SPI data communication log to get more close look at how it works.